Welcome back to our Scala classes, and today we will continue looking at object-oriented programming concepts, and we will look at inheritance in object-oriented programming, in Scala in particular. So the idea, this example actually is from a different language, but the whole idea is the same everywhere. We have some base class which maybe has some methods, maybe has some fields, some properties, and we can create a derived class which we don't have to type all the extra things already common for all animals. We just add some extra functionality, so we inherit the properties and the methods from this base class, and we have this subclass basically. So you can think of this as a superclass and this is a subclass, right? So the idea is reusing the code, right? We only have something which is almost suitable for us, and we can use it for us in a more add some extra functionality. So let's make something more. So I'll make another file. Start for Scala class object on day 14. Inheritance, right? And this is probably, it's a little bit trickier than most concepts because there's a lot of variation, a lot of technical details. So notice again, so this extends up, right? It always shows up, right? Extending something, right? Maybe there's something into it. So class, so inheritance, right? And well, we'll need something to inherit. Again, I guess I'll make it in one file. I could have used two files. So let's make a vehicle, right? Let's make a class vehicle, right? Very generic class, and let's assume for now we're not going to give any properties, but I will add some methods for now, right? I'll add some methods, right? And of course I don't need this right here, right? And I'll have method move. Let's say move, right? Define move, right? You know, something really silly, right? And line moving, right? Something very silly, right? On unit, of course, this is a unit, right? So nothing, right? Okay, so we have a unit, right? So we are going to derive a car from it, right? So we can do derive class car extends vehicle, right? And again we can do define drive, right? Unit, and we are going to drive, right? Driving, right? First, now very simple, right? So hope I'm recording this. I am recording this indeed. So I'll make a, so if I make a val just generic vehicle, you know, new vehicle, right? Nothing to combine, right? And do I have anything? Can I do this actually? Yes, I can. No errors. So vehicle, because I'm lazy, right? Move, right? And it will work, right? And similarly, my car, right? New car, right? My car, right? I can do basically new car, right? And now I can gain ability to, my car can move, right? But also, so I gain ability, so I inherited the ability to move from the vehicle, you can say parent superclass, basically, right? And of course I have my own, I have my drive, right? And this is my own ability, right? Method here, right? So that's the basic big idea, right? So far so good, right? Why did I say day 14? I don't know why. I should probably rename. We're still on day 13, so I'm going to rename that. Refactor, rename file, rename, right? Day 13. Sorry about that. Refactor. And yes, and this also should be day 13, right? So seems to be, let's be more strict. Let run. Yeah, works fine, right? Is the file still 13? Yeah, it's 13. No, it's yeah, day 13 inherited. Okay, that's all good. It's all good. So So that's the basic idea. Well, the thing is, the fun starts when we want to add some abilities, right? Maybe we want, of course, there's nothing wrong with adding some wheels, right? Number of wheels, because vehicle in general might not have wheels. I don't know. Maybe it's floats, right? Maybe it's a boat, right? Maybe it's an airplane. Well, airplanes do have wheels, but cars definitely do have wheels. And since I'm lazy, I don't want to break my code. I will put it's an integer, and I will say 4, right? Since I'm lazy, right? Okay. So of course this is publicly accessible, and I can print line. My car already has 4 wheels, right? Wheels, easy, right? So that is nothing changed, right? The tricky part starts when we want to extend. So what could a vehicle have? Maybe it has a shape. You know, maybe a shape could be good. Ability, right? Maybe color. Well, vehicles could have a color. Let's do a color, right? So are we gonna do internal or external? I'll do it external. Let's say color, right? Assume they not change, right? I'll just add color, right? So now I have a problem. If I add this color, how do I add it here? So basically I need to pass it basically here, right, as color, right? Extends vehicle with color, but I need to use it, right? I need of course put the type too. Let's say string, right? So let's do string, right? So that should be better. Still, it's still complaining. I have to say, I guess, string. I think this is how to do this. No, let's see why this again. So it's a little bit tricky, this part here. This is a tricky part. So we are extending. I don't have to say anything actually. It should be automatically extends vehicle color, but I need to use it here, of course. I'll say again maybe var color, right, or val color string, right? Oh yeah, okay, it's complaining. Override. So I need, let's say var. I'll do var. I do need var. Right. Oh, I do need to define that it's incoming. Let's say if I did this. Okay, so I can use it like this. So now it becomes internal. Let's see if this works now. Color, color, color. Let's see if this actually is exactly what we want. So syntax-wise, we seem to be fine. Again, IntelliJ is holding our hand. So we have this property field in a vehicle as a color, and we need to pass it along from their inheritance, right? Otherwise, there would be a problem, right? So we need to somewhere supply it. Could I do something else? Well, I can't really, right? I mean, so it's coming in, right? Here, and we have something new. So, of course, here we have a problem. We'll have maybe gray, right? That's no problem. A new car needs what? Wheels are not required, by the way, right? So I could say maybe I have 6 wheels, right? But color needs to be red, right? And everything should work. The question is, do I have access to color? That's a good question now, because here we define publicly. We can obviously print line vehicle color, right? No problem, because we define by val. So getter is made for us here. No problem so far. The tricky part is here about the color. So wheels, no problem. The question is our color access. Do I need override here? Yes, I do have color. Is it red? No. So I do have access to red. So that's slightly, I think, language-wise, again, slightly tricky, because the override method was needed, right? Because so basically it's coming. So color, the syntax needed to pass these values along from your parent is slightly tricky, right? Because you used val or var possibly. Here you use nothing, right? Right. And so that's slightly off setting, That's why inheritance is a little bit tricky to use. But let's run it. Yeah, so everything works properly. Gray, moving, driving, 6 red, everything works. Methods work. Passing along works. So publicly, so if I made this by default, if I had made this var, what would change? Let's say changeable color. Would anything break? No. So by definition should be my car. I should be able to change now, right? My car color is now yellow, right? It should be no more an error. And it is not an error. So of course I can print my line. My car color you know, is not an mutable because parent property color was mutable as well, right? So not too bad, not too bad. So let's see, can we extend, if this idea makes sense, let's see if we can extend this to case class. So will anything be different? I believe nothing much will change, but let's make a student, right? We have student, right? Let's make a case. So we have a case class person, right? Case class here. We're going to try to inherit from that. So it's slightly trickier, but let's see. So I suppose I should make it case class as well, right? So since let's see if that actually makes difference. Like, let's say student extends case class, person, right? So what do I need, right? Do I need anything, right? Student needs a case, class student, right? Class student extends person. So person, of course, needs these three values, right? The name, value, so of course, again, name, string, right? Relation string, on top speed, again, top speed int, right? Yeah. Okay, and that's not it, right? Name, person, name, relation string. Maybe I need to put, maybe again I'll put 180. No, that's not it. So I need, of course, student needs, of course, these values. Again, so our IntelliJ is not that helpful as I would like it to be. But for now, I'll do this name, relation, top speed. Of course, I need to define these, right? Well, actually, I didn't, right? So it turns out I don't need to actually do color here, right? Because automatically, right? Well, it says nothing, 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 right? I'll need this actually as well, right? It's path coming automatically as well. So I do need to say, right? I need to say this is a string. So string, right? Relation string. On this last one I need to fix. So integer, right? So I do need to say the types, right? Okay. And now it should work, right? Of course, I would like to add a school. Let's add a school somewhere, right? I'm going to add a school here, right? Or class, or grade. Let's do grade. Let's do grade. So it's probably variable, right? Grade, you know, grade, of course, integer, right? So now everything works. Everything works. Okay, great. So we have our extends from person, and we have, again, so we have to specify what are we inheriting from our person, right? And of course, it has to match, right? What happens if you don't want to inherit everything? Well, we'll use traits, we'll use something else for that. So grade, we have something new. So now let's make a new student, right? So let's say make Maya, right? Equals new student, right? Again, it's a case class. So the question is now, can I do this? Student, yeah, let's see. Let's say grade 3, right? So 3. And do I have to type maybe new? Do I maybe have type new here? Yeah, I do have type new. So probably have made case class, right? We'll check if this is actually, it would make more sense if you're extending, inheriting from class, right? Probably better to use actually, so Maya, right? And we will do relation daughter. So daughter, and we will do, you know, 250, for example, right? Top speed is 250. Okay, right. So everything is correct, looks like, and it should work. Print line, Maya. Let's see what happens when we print. Will we have all the properties? Well, so this is an interesting question. Since person was a case class which already did some things behind the curtain, did some things, right? And of course, the inherent increase the speed should be available. That's for sure, right? So that should be available, right? We're reasonably sure we can increase their speed. My increased speed is still available. You see, so in that part it's very nice. So I'll do maybe 200, right? So on, well, Maya, print line Maya. Okay, let's see what happens. It should be, since we are inheriting, it should be the, or we have a class, but really we are getting all the cool stuff from case class. We'll see if that's really the case. That would be a good experiment here. yes, it works perfectly. So we actually did inherit everything. I would probably still, let's see, again, so can we get rid of this new? Well, if we inherit from a case class, can I make it a case class? Will anything change? Well, can we make it case class, inheriting from case class? Ah, suddenly this doesn't like it anymore because you have to define these other things as well, right? So you have to probably make everything, or we need to override then automatically. Why? Because remember that by definition in a case class inside all of these were values. So what happens, so basically I've wrote val. Can I make, so if I'm extending it, this will be trickier. So that's why I probably stick with class today. I could make an employee or maybe a teacher, maybe, right? And again, so if I did case class, right, teacher, I would have to write a lot of work again. So school, maybe, again, so val school, right, that would be easy. But then, right, let's see how much time, let's see, this gets trickier. Right now we still have some time, so it gets trickier. And of course, since I'm extending, right, extend person, right, hopefully teachers are still persons, right, I need to get all of this, right. So, right, okay, and I'm not using it, right. So well, again, if I want if I don't want to use, well, then why extend this, right? So you say, okay, I want some properties, I don't want all the properties, I want only some. Well, for that you have traits, which we'll look in another lecture. So for now, we could basically, val is actually given, right? Case class, it's already, remember, it's default, right? Val is default. So if I do this, let's try this. Name string, relation string, right? On top speed, integer, right? Okay. And it's so school, right? Okay. So this needs override, right, on name, right? Okay, so that's the way it does. So let's see if it is on. I need to say something. Let's see. I need to say what it is. Let's say val. Yeah, okay, that's how to write. So basically extending a case class with another case class gets slightly messy, right? So that's what I have to write. And not very, maybe not as nice as standard inheritance from standard. So vehicle car, much easier, right, from class to class. If you because case class has lots of extra things behind, right? So you have to override again val or var, right? You say, okay, var of course here, right, because this is top speed, right, and of course integer because it is an integer, right. I could have used val as well, right, if I say one stock. So I need to add this override ability. So for case classes, creating a case class by inheriting from another case class gets slightly more complex as we have to override already set access methods, access how to say level access categories in original case class, right? So again, so of course one other thing, of course, we have not talked is what happens again. So this is of course we have some things of constructor, right? This is constructing generic vehicle, right? That's constructor vehicle, right? That's a constructor, right? Because this whole thing is constructor, right? Of course, this is method inside constructor, but we are defining it, right? Finished construction, right? Remember, it's from our previous lecture, right? Print line, not printing, but print line, right? So now let's see, we did this here, right? We have some methods, and let's see if we can do. Let's do some more. Let's see if everything runs. No, something did not work correctly. Right. So has a case instead of person, but case. Aha. So it's actually not even allowed. It's not even allowed, right? Presentation use extractors to pattern match and non-lethal. So yes, so basically even extracting a case class is not even allowed. So that actually solves our problem, right? So we can basically say class. So we need to extract. So it actually turns out we can't even directly inherit, right? As a case class from another case class, right? So actually, basically, we need to go back to this. Will anything work now? Yeah, it will work. We're not using school. Oh yeah, I need, of course, I should use promptly do something, add something here. My class in session on name residing at school, right? Okay. So that's a constructor on teach. Let's say at define teach, right? And we'll add a method, right? Unit again. Teach. I'm line as honorable name teaching, right? Okay, right. So now, of course, unit. By the way, since for these public methods, you need to actually explicitly mark them. Otherwise, when you commit, IntelliJ complains you have no, you're not being very right. You know, not being a nice citizen, basically, because it makes job harder for the compiler, for IntelliJ to check what kind of types you are getting. Okay, so car, vehicle, student, right? So teacher, right? We are actually already all right. Do we need this, by the way? Okay, so we don't really technically need this, right? Because basically, right, we could have stuck with it, but okay, let's stay with this, right? Let's stay with it and run it. So I'll make a new teacher, right? Maybe I don't know. Teacher, right? New teacher. Teacher equals new, right? Teacher. And of course, I need to say some things right here. Okay, so name, school. Let's say Rosenthal. I don't know, or Hansa, right? And I'll do maybe a name will be I don't know. Lapinch, I don't know, that's a Latvian name, maybe something relation, well, relation's a person, I don't know, what will be relation, acquaintance, and speed will be, I don't know, 600, right, okay, right, so, and of course, new teacher can teach, right, okay, so, let's run it. Okay. Okay. So mutable variable cannot be overwritten, right? I said top speed, and I think I did something here. Mutables cannot be overwritten. So here, this is a problem, right? So I don't need to override this, basically, right? Just like student, right? Yeah, now it works fine. Honorable Lapinch teaching, right? And of course, I still should be able to get a new teacher, right? Yeah. Yes, and of course, I still just like student, I still have access to pretty print, since super class was in fact a case class. So yes, it's okay. So yes, if you are going to inherit from a case class, you need to just use regular class, right? Of course, again, so methods, they can be passed along, they will be automatically, the whole thing is that methods get passed along, right? So question, do we have class in session? So notice something here, right? When I make a teacher, right, this constructor works. Question is now, do persons, well, persons don't have anything here as a constructor, right? New person created. I could of course add it here. Let's add it and see what happens, right? So print line person creation started, right? New person created, person line, person has been created, his name, right? Something like this, right? Of course, these are kind of silly examples, right? But again, idea of construction, right? So let's see if this actually works. What's the order of these constructors, right? Because we have a concept. So yes, see, person creation started, person has been started, his name Lapinj, and then class and session presiding. Let's see, on the honorable light. So this part here, right, is from the second so both constructors. So this is so first the super constructor will be called constructor will be called. Then we start our own subcontractor, so to say, right? Since we are inheriting. So yes, so your generic person constructor starts first, right? It puts all the stuff that moves ready. It does all the stuff. You know, we add more code, more construction here, right? And then we run our inherited class also starts as constructor. Of course, it all happens only when you have a new object, right? When you create a new object. Okay, so I hope you got some idea of how inheritance works. In general, you don't inherit too much. Generally, you don't inherit too much, but let me give you, maybe here is a class constructors, and I want to show you maybe, well, yeah, so classes, right? Do we have anything about in classes here? Inheritance, I don't think it mentions here, right? But we'll talk about traits in a moment. So again, so classes can inherit from other classes. So open question remains. So if we want to inherit from more than one class at once, we will need to use traits instead for additional classes. Instead, so for additional inheritance. And that's another topic. So topic for another lecture, for maybe later on we will look at that. So in the next discussion. So thank you, and we will continue.